We shall be looking at some kinematic questions. So here is the first question. Three posts P, Q, and R are fixed in that order at the side of a straight horizontal road. The distance from P to Q is 45 meters, and the distance from Q to R is 120 meters. A car is moving along the road with constant acceleration a meter per second squared. The speed of the car as it passes P is u meter per second. The car passes Q 2 seconds after passing P, and the car passes R 4 seconds after passing R. Find Roman figure 1, the value of u, and Roman figure 2, the value of a. Alright, so in order to solve these questions, this kind of question, you need to take it line by line, or let me say phrase by phrase, so that you not miss out of anything. So here we have three posts. P, Q, and R are fixed in that order at the side of a straight horizontal road. So we can take it that here we have the horizontal road. We have P, we have Q, and we have R. So these are the three fixed posts on the horizontal road. The distance from P to Q is 45 meters. Okay, so let's indicate that in our drawing. Okay, so we have 45 meters here, and the distance from Q to R is 120 meters. So we have 120 meters. That's from here to here. That's 120 meters. And then from P to Q, we have 45 meters. All right. You can see that in all, we can take the entire length to be the addition of 45 and 120, which is 165 meters. So that's the length from P to R. The question continues. A car is moving along the road with constant acceleration of a. So meaning that the car keeps accelerating constantly from P to R. Now the speed of the car as it passes P is u. Okay, so we are going to take it that from P to Q, that's the first journey. The initial velocity, let's take that as u, is unknown. We do not know what it is. Okay, and then we're told that the car passes Q 2 seconds after passing P. What does that mean? It means that from P to Q, that was 2 seconds. So the time that the car used to move from P to Q is 2 seconds. So let's state that the time is 2 seconds. And then the car, okay, and the car passes R 4 seconds after passing Q. What does that mean? It means that from Q to R, it took 4 seconds. Okay, so we are permitted to state another journey here. We can call it Q to R. Okay, the time from Q to R is 4 seconds. Okay, so find the value of u, which is the initial velocity. All right, so in this particular question, there are quite a number of things that we do not know because we're not given. All right. Um, we can look at it by saying that initially that was initial velocity, which is u, and then it got to q. Let's call that the final velocity. That's the first final velocity. Okay, so we can call that v1, which we do not know exactly. Then we can say that from q to r. So from q, it's going to have the v1, that's the final velocity of the first journey. Okay, the final velocity of the first journey is going to be the initial velocity at for the second journey. So we can say that v1 is also unknown from here, and then we can say that there's a final velocity at r. We can call that v2, or we can call it vr. So let's call that v2, which also is unknown. Now another thing we're given in the question is we're given the distance from P to Q. So the distance represented with S, we have it as 45 meters. Okay, then the distance from Q to R, we're given that as 120 meters. There is something else we can deduce from this question. Okay, before that, we were given an acceleration which was constant all through. So whatever concentration, whatever acceleration which we get from P to Q, so also the acceleration from Q to R. So because that is constant. All right, there's a deduction we can pick up from this diagram. We can pick up that, you know, the journey from P to R, that is the straight journey, that's P to R, okay, has an initial velocity which we do not know. It has a distance which is an addition of 45 and 120. That gives us 165 meters. Okay, and then the time it took it from P to R, the time it took it, that's going to be 2 seconds plus 4 seconds. That's 2 seconds from P to Q, and then 4 seconds from Q to R. Okay, so that's going to be 6 seconds. So the entire journey from P to R took 6 seconds. All right. Then the acceleration, of course, is still constant like every other section of the journey. Now, how do we proceed? We want to find the initial velocity. Now, at this point, what do you think about in order to solve this? The first thing I will always suggest is have at the corner of your book, because this is a question where you need to use the equations of motion. So you can have at the back at a part of your book where you have the equations of motion, which we have as v equals to u plus at. We have v squared equals u squared plus 2as. We have s equal to ut plus half at squared, and we have s equal to v plus u over 2 multiplied by t. So these are the 4 equations of motion. Now, why do I recommend having it somewhere written? Or I mean, there could be formula book. The essence is for you to look at the things you were given and then to see what you need to get or what you need to find. So in this particular question, we're asked to find the value of u. And to find the value of u, if we consider all these parameters, we were given Okay, so if you consider these parameters, you realize that from P to Q, we were given, let me just say two parameters there, which is time and seconds, time and then the distance. And so also for Q to R and likewise P to R, we're given two parameters. So in a case like this, you will find out that you need to resolve to using to having a simultaneous equation where you are going to have two equations to solve. Because I think you have been given up to like three parameters, it could have been easier for you to just say you solve one of the equation first to get one of the unknown parameter. Now the next thing now is that which of these do we make use of? Looking at it intently, we were given time and distance, so we are going to consider the first equation here. We are not going to consider because there's no distance given there. So we can consider the second, third, and fourth. Okay, why? Because okay now, so we're not going to consider the first one. Yeah, we're not going to consider the second one. Reason being that the first one we do not have distance. The second one we do not have time. So because of that, we are taking those two out. We are going to consider the use of either the third or the fourth. Now, if you are going to use the third one, we're given the distance, which is s, we're given the time. Okay, we're told that acceleration is constant, which is a good point which has been given. So we have an acceleration which is constant. Then we have u, which is the initial velocity. So I would say we should use the third equation. Now let's consider the fourth one. In the first equation, yes, we're given the distance, which is we have s, we're given the time. But if you consider that we have v plus u, there was nothing said about any of the final velocity, maybe velocity at a, or or the final velocity from P to Q, or the final velocity from Q to R. Okay, nothing was mentioned. And then they gave us a clue, which is acceleration. So an acceleration is not in the fourth equation, so that's why we should use the third equation. Also, in the third equation, we have just the initial velocity. And if you consider the this journey, which we have in three sects according to what you have on the screen here, P to Q, Q to R, and P to R, we would rather use this first and third because it looks like it's something more straightforward. For this second one, we have V1 and V2. Both of them are kind of so unknown. So those are three things. These are two things that we do not even know at all in the journey. But we need the initial velocity, which is u. So and then we need the initial velocity, which is also u. So I would suggest we use those the first and the last one. So how do we proceed? Our equation is s equal to ut plus half at squared. The distance in the first part of the journey, that's from P to Q, is 45, which is equals to the time is 2, so that's 2, and then the initial velocity is u, that's why you have it as 2u, plus half, the acceleration is unknown, and then the time given is 2, so that's 2 squared. All right, so the next thing now is, let's simplify this. That's going to be 45 equals 2u, and then 2 squared, that's 4, then half of 4 is 2, so we have 2a over here. So we have this as our first equation. Now we can solve it alongside the other one, which you're still going to use the same equation of motion. The distance for the second for this other one is 165 meters, so we have 165 meters equals to, the time is 6 seconds, so we have 6u plus half, the acceleration is unknown, we have it as a, and then the time squared, which is 36, or have it as 6 squared. Okay, so let's simplify this. We have it as 165 equals 6u plus 6 squared is 36. 36, half of 36 is 18, so we have it as 18a. This is the second equation. Now we're going to employ the use of simultaneous equation to solving this. So we are going to multiply the first equation. We can eliminate u. All right, to eliminate u from the two equations, multiply equation 1 by 2, multiply equation multiply equation 1 by 6, and then multiply equation 2 by 2. So multiplying equation 1 now, 45 multiplied by 6 Alright, so 45 multiplied by 6, we have 270, 12u, and then 12, and then we have 12a as the first equation. So let's call that equation 3, and then the second equation, multiplying it by 2, that's going to give us 330 equals 12u plus 36a. So let's have this as equation 4. Now, considering that this is 330 and this is 270, the 330 is quite more than 270, so I'd rather make it equation 4 minus equation 3. So 330 minus 270, that will leave us with 60. Then 12u minus 12u, that leaves us with 0. And then 36a minus 12a, that leaves us with 24a. So we've successfully eliminated u. Okay, then we find the value of a, which is 60 divided by 24, and we're going to arrive at 2.5. So we have the acceleration as 2.5 meters per second. So it's easy for us to find the value of a, which is, okay, so we've gotten the value of a, which is the second. Now to get the value of u, we can substitute into any of the equations, either equation 1, equation 2. So let's use the first equation. So the first equation, we have 45 equals 2u plus 2a. Alright, we know the value of a right now, so we have it as 45 equals 2u plus 2 into brackets 2.5. So we have 45 equals 2u plus 5. 45 minus 5 equals 2u. So we have 40. We're going to have 40 equals 2u. So we have 20 as the value of our initial velocity. Yeah, let's consider this next question. It says that in taking off, An aircraft moves on a straight runway AB of length 1.2 km. The aircraft moves from A with initial speed of 2 meters per second, moves with constant acceleration, and 20 seconds later it leaves the runway at C with speed 74 meters per second. Find the acceleration of the aircraft and then the distance BC. So let's put down the diagram of this. Now, in taking off, it says that the airplane moves on a straight runway AB. So we take it that the runway is A to B, and that is 1.2 kilometers. Okay, so that's the entire distance, 1.2 kilometers of the runway. The aircraft moves from A with initial speed of 2 meters per second. Okay, so let's put down some of the parameters we've been given. So we have the initial velocity, which is 2 meters per second. Okay, and then it moves with constant acceleration, and 20 seconds later it leaves the runway at C. So meaning that it is still within the runway, and the runway actually is from A to B, which is 1.2 kilometers. So it means that there is a place in between the runway, which is point C. So it's possible that we have point C somewhere around here. So what we know is that from A to B is 1.2 kilometers according to what is given. A to C, we do not know exactly what it is, but let's read on. So, but we know that it moves with constant acceleration, and 20 seconds later it leaves the runway at C with speed 74 meters per second. Okay, good. So meaning that we are going to have two of the journey broken down. So let's say that we have A to B. Okay, we can have A to C, we can have B to C, or let's say C to B, either any way we want to put it. So now that said, we know that the distance from A to B is 1.2 kilometers. We know that the initial velocity we're given as 2 meters per second, and okay, and then we're told that from A to C, we do not know the distance from A to C, we're not given. Okay, this is 2 meters per second over here. Also here is 2 meters per second, 2 meters per second. Then the final velocity when it took off was 74 meters per second. Okay, the next thing is we're told that the acceleration was constant all through the journey. It was constant all through the journey. Now so I believe you understand the illustration of the journey. We don't know the distance from A to C. So the question now says that we should find the acceleration of the aircraft. Now, like I always do, have your equations of motion, somewhere so that you can easily understand what you are given and what you are to find. Okay. Now, don't let us forget that we're given the time that it took off at C after 20 seconds. So if you consider this second journey, which is A to C, it looks like it's more complete. We have U, V, T given. So all you need to do is to consider the equations of motion and know which of them have, you have all these things given. So if you consider v equal to u plus at, that makes a lot of sense because v were given, u and t were given, so a is what we are to find. Okay, so we use that v equals to u plus at. The final velocity is 74, the initial velocity is 2, the acceleration unknown, and then the time is 20 seconds. So okay, this so based on what we have been given, we have been given the final velocity, which is v, the initial velocity, which is u. We've been given the time, which is 20 seconds. So we can make use of the equation. We can make use of v equals u plus at. Okay, the final velocity is 74, initial velocity, that's 2, acceleration is unknown, the time is 20 seconds, so that's 28. So we have 74 minus 2 equals 28. Alright, then you have 72 equals 28. A equals 72 divided by 20, and that's 3.6 units, meter per second squared. So we found the value of our acceleration. Then the next thing is we need to find the distance BC. All right. To find distance BC, we have the distance from A to B. It's for B to C. We're not giving much information, so we can't really use that to calculate. But we're given some information from A to C. We're given the initial velocity, we have the distance, and now we also have an acceleration which we've gotten, which is 3.6 meter per second squared. All right, so because of that, well, let's find the distance from A to C and then subtract it from 1.2, which is A to B. All right, so in order to do that, we can make use of one of the equations of motion, which is S equals V plus U divided by 2 multiplied by T. Okay, the distance of A to C we do not know, but we know the velocity, the initial and the final, which is 72, which is 74 plus 2, okay, divided by 2, and then multiplied by the time, which is 20. So when we solve this, 72 plus 2, that's 76 over 2 times 20. When we solve this, we would have 760 meters. All right, so that's to tell us that from A to C is 760 meters. Now, if A to B is 1.2 kilometers, you can convert that to meters first. That's 1,200 meters. That's from A to B. All right, then A to C is 760. So when you take 760 from 1,200, you find out that you have 440 meters. So therefore, the distance from B to C is 440 meters. Thank you.